Gotta watch out for this aircraft here. Okay. So, as I said, I was the cloud architect at Netflix, but 2.5 years ago, I left Netflix and I joined Battery Ventures. And on my first day at Battery Ventures, at my first meeting, they said, well, we've just made an investment in this thing called Mendix, this company called Mendix in Holland. And that was my introduction. We both started on the same day, so I've got a bit of synchronicity there. And I've been looking at building up platforms, building up a platform at Netflix. We open sourced a lot of what we built, but there's a whole cloud-based infrastructure, lots of different pieces you can put together to build something. And then on top of that, it starts to build, people can build on top of that. So then you build more and more layers on that platform. What Mendix have built is a platform that makes it simple. And as one of the things that Simon Wardley talked about yesterday, you take these, as you build the platforms, you take things that used to be complicated and used to be at the bleeding edge, and you move them to become more and more evolved, and that causes a whole new thing to be built on top. So what Mendix is able to build is enabled by all of the underlying platforms, all of the underlying cloud development that's happened over the last 5 to 10 years. So what we've got now is something that lets you build things really quickly and really simply. So I wanted to spend some time talking about what does it mean to be simple. And I'm going to talk about it in a few ways. I'm going to talk about what it means to be simple in our lives, in the way we work, and in the products we build. So let's start with a question. This is one of the most complicated questions you could possibly ask, right? But it has a very simple answer. Everyone knows, what is the meaning of life, the universe, and everything? This has been around for a little while now. The answer is 42, right? That's a very simple answer. In fact, if you go around people that have, people that ever heard of this, if you just mention 42 to people, it sort of pops into their mind. Oh, yeah, that's the answer to life, the universe, and everything. It's become a meme, right? So now we've taken some big, complicated thing, and it's now represented by a very simple concept, a very simple sort of label. So that's an interesting sort of way of thinking about it. So life is complicated, right? There are many, many complicated things we do, but we develop simple abstractions and we deal with it. So when you say something, if you come across something new and you say, that is just too complicated, I can't really deal with it, it's way too hard. In many ways, what you're actually saying is, it's got too many moving parts and I haven't got intuition about how it's going to behave. And what happens over time is we do develop the intuition. So things that are complicated become less complicated as they become more familiar to us. So how do you develop that familiarity, and how do you get things that are, how do you get to that point of familiarity more easily? So what's the most complicated thing that all of us do intuitively? You think about that. What did you do today, most likely? What's the most complicated thing you do every day that you can do with barely thinking about it? Yeah, somebody says driving a car, right? We expect just about everybody in our community, almost, very high proportion of the people in in our communities are expected to be able to figure out how to drive a car. It's one of the most dangerous things. It's one of the most complicated things. You put somebody that has never seen a car, let's say they grew up on a Pacific island and were disconnected from the world, and you bring them here and you sit them in a car and you say, okay, drive across town. I mean, they don't know how to operate it, they don't know the rules of the traffic, they don't know what's going on. It's a mind-bogglingly complicated thing to do, but we expect everybody to figure out how to do it eventually, right? And now, of course, we have 18-year-olds winning Formula One races, but, it's just as a more extreme example. It is actually, sometimes it is a very complicated thing, and with a lot of training, you can actually do a lot there. So that's an interesting problem. And let's just think about some of the complicated things that I do with cars. Well, I have this very complicated car. It's a Citroen with a Maserati engine. It's a 1973. And I won an award at a competition last summer in the needlessly complicated Italian category. Turns out that I actually entered the French category, which is called the unmitigated gall category. This is in a spoof, sort of funny concours event that happens every summer in California. That's a picture of my wife. And the reason I won this award was none of the Italian cars made it to the event. And so I won by default as the most Italian car that actually turned up and had some Italian engine in it and was actually incredibly complicated. So, for me, a car isn't just a way of getting A to B. It's actually a complicated thing I have to try and maintain as well. So what's another complicated thing? Think of something that is so simple that anyone can do it. Think of something your children can do, right? What do they probably spend most of their time doing, right? They probably spend most of their time glued to an iPad or something like that, playing games, playing around with things. And this came home to me, I think it was in 2008, 2009, really only about 6 months after the iPhone came out. We were standing around, actually, at a friend of mine, actually a Dutch friend of mine, who was having a party at his house in the Bay Area. And somebody had an iPhone, and they had a 2-year-old daughter, and he was carrying the daughter, and she was, you could barely tell what she was saying. She was mumbled something unintelligible to him, and he got the phone out, gave it to her, and she started browsing YouTube for SpongeBob videos or something like that. And the rest of us are looking at him like, how did she learn how to do that? It was a real eye-opening moment that, somebody who can barely talk was operating one of the most sophisticated things that the human race has ever made. If you think about what is in a smartphone, you think about the hardware that's in it, the radios that are in it, the back-end services, everything that's in the modern smartphone. It's an incredibly complicated device. But it's simple enough that you can give it to somebody that you can't train, you can't read the manual. 2-year-olds don't read manuals. She reached into the phone and she was operating it intuitively. So that is something that goes way beyond thinking about a car, right? Cars, you spend years to learn how to drive them, and they're incredibly complicated. But once you've learned, you drive to work and you barely remember driving to work. But an iPhone is something, or an Android, whatever, a modern smartphone, something that is so intuitive that you can reach right into it. So how do you get to that kind of thing? So, of course, we take those, and this is what happens on my phone. If I gave you my phone, you wouldn't be able to find anything. I pick up my wife's. We've customized them to the point where there's hundreds of apps, and they're arranged in complicated ways, and so we actually get makes it a bit harder to figure out. But I wanted to bring up this thing on the right here. Randall Munroe, the guy that writes the XKCD cartoon, wrote a book explaining Thing Explainer, complicated stuff in simple words. He only uses the 1,000 most common words in the English language to explain everything. If you look at this is a hand computer, and it has a power box, and it has all these other things. Without using any technical jargon, he was able to explain what is inside a phone. So that's an interesting concept as well. How do you communicate these things in simple terms? It's a great example, and it's a great fun book, and it's something you should all buy and particularly give to your kids to explain how everything in the world works. So moving on from that, obviously in our personal lives we can deal with really complicated things, and we can learn how to deal with things, and we can come across extremely sophisticated systems and figure out how to use them. But let's think about what happens in our work environment. How do we simplify what we do every day as we get things done? Well, one of the interesting things that came out of Netflix was the culture deck. This was put up in 2009 as a set of slides on the SlideShare account. It's now had, I think, last time I looked, 13 million views or something like that. And Sheryl Sandberg, who's the CEO of Facebook, said it may be one of the most important documents to ever come out of Silicon Valley. This is a document describing the culture of a company. So what is different about this company? And this was one of the things I found fascinating about Netflix, and it's one of the things that I've tried to share as I've talked to companies going around and people like Mendix. This is just one of the slides from it. If you want to build a ship, don't drum up the people to gather wood, divide the work, and give orders. Instead, teach them to yearn for the vast and endless sea. That's from a story called The Little Prince, which actually Netflix has a cartoon version of The Little Prince coming out in a few months' time. But it's an interesting thought. So the way we're taught to manage, the traditional management methods is that there's a brain. This is called Taylorism, right? There's a brain who is going to tell the workers what to do. And you break everything up, and you basically, everyone does what they're told, everything will happen properly. That's sort of the manufacturing product line idea of building things. What we're talking about here, though, is more like a purpose-driven culture, like the purpose. We're going to find a bunch of people who are going to inspire them with a thought that we want to yearn for the vast and endless sea. And then as a side effect of that, they'll probably build a boat. And they'll build a better boat than you could have told them to build if you'd actually given them instructions on how to do it. Because they have the idea of where they want to end and what they could do is what's driving them. So this is actually, in some sense, rather than focusing on the mechanism of how you get there, you're focusing on the inspiration and the purpose. And this is an example of systems thinking. Okay. The system that you're putting in is to have a purpose-driven culture, and everything else will work itself out from that. So what we've found, another key thing with Netflix, is that every time you impose a process, you block everything down, it actually drives talent away. And Netflix is optimizing for talent density. They want the best people, and they want the best people to stay, and they want to get the most out of the best people. And you don't do that by making everyone follow rules and follow a process. You do it by getting out of the way. And I was doing a presentation to a bunch of executives a few years ago when I was still at Netflix, and they said, this is all very wonderful, but we don't have those kind of people. We can't do what Netflix does. And I look around the room at the name badge and it says, well, we hired them all from you. You already, we don't have a cloning machine where we push a button, another Netflix engineer pops out. They're all senior people. They all worked at the kind of companies that were in the room. But those companies were systematically frustrating them, locking them down and not letting them be what they could be. When those people came to Netflix, Netflix got out of the way of the innovation and let them flower and let them go. And one engineer said, he was kept in a cube at his previous employer and told to work on these things and wasn't allowed to share what he was doing. When he joined Netflix, he said, he was like, we gave him wings. We stuck wings on him and said, go, fly higher, fly harder. We kept pushing him, and he became a very well-known industry figure. Built one of the Netflix open source projects and made a big difference in the industry. So that kind of experience happened over and over again. So think about that as you're organizing what's happening in the organizations. You don't make things simpler by having one process to follow. That is simpler in one reductionist way. You make it simpler by having a purpose and getting out of people's way and creating a system around people so that they can go and contribute to that purpose. So, purposeful systems. This is from a book called About Systems Thinking. I keep mentioning this by Jamshid Gaharajadagi. I'm going to figure out how he pronounces his name on Friday because I'm actually going to meet this guy. I kept quoting this book, and eventually I got invited to the executive MBA class that he actually is teaching. And anyway, they're having an alumni reunion on Friday, and I'm one of the speakers at it. Anyway, the system thinking book has this idea in it, purposeful systems. So we're building something for a purpose, which is the systems view of development. And I'll try and explain what this means. It assumes plurality of function, structure, and process. This is a fairly complex statement, but what do we mean by plurality of function is that rather than saying this thing does one thing, it means it can do different things for different purposes. Think of a car. We were talking about cars earlier. What is a car for? What is its function? For some people, it's to get you from A to B. It's to get you here today. Other people, it's a status symbol. I got a Ferrari in my driveway. That makes me into a different kind of person than somebody with a Toyota in my driveway. Or it may be me taking my strange old car to a car show and having fun with it. Mostly people going around, hey, I haven't seen one of these for years. or it might be Max Verstappen winning the first Formula One race, right? Those are all functions of a car, but that's a plurality. They all do different things for different people. As soon as you lock it down and say it's just got a single function, you're actually losing a lot of the value. So this is part of this systems thinking approach, is to let the system get loose in terms of functions. Plurality of structure, rather than saying you have one hierarchy in the organization and everyone has to work a certain way, you recognize that there are social structures, there's family structures, there's all kinds of structures in an organization, right? And how do you, different ways of working with each of those structures. And then process, rather than having a single way to get things done, if everyone's aiming at the same target, it doesn't really matter how they get there. And what you're trying to do with these purposeful systems is build environments that can evolve. And this is the fundamental goal of all of this systems thinking approach, is to build products that can evolve, processes that can evolve, and companies that can evolve. And when you evolve, then you can keep up, because as we were hearing, the world is moving faster. We're getting more agile. We're developing products in minutes rather than weeks and months. We're solving problems quickly. We're enabling, we're empowering people. Products like Mendix go right to the end users and let them create the applications and modify the applications. You're getting closer and closer to people building the things they need. All of that speed, like if before I hit deploy on my Mendix application, I had to go get approval from a vice president to change the color of that button, right? That's not working, right? That's the processes that people have today in some of these sort of large, complex things. So think about that. It's a really interesting book to go look at if you want to stretch your mind a little bit. So systems are simple and flexible. You have simple rules, and they cause what looks like chaotic, disorganized organizations. If you think about an ant's nest, it's a complex, disorganized-looking thing. But if you drop a piece of food next to it, all the ants will rush out, pick it up, and take it back, right? They have simple organizing principles that cause them to operate. But when you look at it, you can't say they're all following a process. The more rules you have, the more rigid you get, and the harder it is to evolve. So that's the point I'm trying to make. Okay, let's think about the things we build. How do we simplify them? This is Conways Law. That's, basically, it says that the structure of your organization constrains what the organization will produce. And the observation here was originally around software, and that, one of the examples, if you have 3 teams building a compiler, they'll build a 3-pass compiler. That was the original example. Nowadays, what we had at Netflix was a very cellular-based organization where each team owned a piece of the functionality, and they had lots of interfaces between teams. And it was sort of an end-to-end flow of producers and consumers. And when we went and we built software, we ended up building what is now called microservices architecture, where every team built a service, and that service had APIs to the next team. That just reflected the way that they were working anyway. Right? They weren't, the organization was created, and that's the way it went. Now, if you're trying to build a microservices architecture out of your software environment, and you're still organized as sort of this vertically oriented stovepipe system with lots of tickets and meetings to get things done, you'll have great difficulty. So one of the things I find is that as people move to microservices and DevOps and all those kinds of transitions, one of the first steps is actually the reorganization, and this is the top-down. This is why I spend a lot of time talking to executives. They have to get the org chart right. They have to get product-based development rather than project-based development, and get the system so that you've got these local ownership where people are responsible for a piece of the problem with clear interfaces to everyone else. Then everything flows from that. Again, this is a systems thinking approach. You set up the organization, get out of the way, and it will automatically produce the right architecture. And another famous Dutchman, Werner Vogels. This is the principle of DevOps that Netflix ran with. You build it, you run it. We took every developer, we told them, you're no longer going to be building a piece of this monolithic thing that we're going to combine everyone into. You're going to run a piece of the system yourself. You're going to be responsible for deploying this piece of functionality, and you're going to be on call for it. When it breaks, you're the first line of call, being, your phone number is in the list. What happened then was remarkable. It turns out developers can write really reliable code that doesn't break, especially if the alternative is being woken up at 3 a.m. or 7 p.m. on a Sunday night. It turns out the peak traffic at Netflix is 7 p.m. on a Sunday night, which is really annoying because that's when you want to be watching TV with your kids, which is why it's the peak time. So this was the sort of approaching, starting with developers and teaching developers how to operate. It's DevOps coming from the developer end of the spectrum. There's a whole other kind of DevOps, which is operators learning how to automate and build and become developers, basically. And we kind of met in the middle over time. So there's a sort of a blend in the DevOps world of developers operating things, largely the cloud-based, highly automated world of developer-driven infrastructure. And then there's another side of it, which is more API-driven operations, is the other way of thinking about it. And they come together and meet in the middle. So just want to talk briefly about the complexity of applications and monolithic versus microservices applications. People talk to me, because I'm always talking about microservices, my developer-oriented talks, you can find them on SlideShare, I talk a lot about this. They say, but microservices look complicated, but if you look inside a monolith, it's such a tangled mess. It is actually normally a really complex thing. And it's when you try and pick it apart, you find out how complicated it really is. What microservices do is they enforce separation. They have teams, have good APIs between them. It separates things, and it makes it overall less complicated. But when you draw an architecture diagram, there are more things on it, but the interior of those things is much simpler. They're much easier to deal with. I've actually built a microservices simulator. We're talking about IoT today. This is a model of an example React-based IoT reference architecture for a multi-region deployment. Each of those little dots is a microservice, and the links between them is the traffic between them. And this was for something like a typical thing like, say, a consumer device where it's ingesting data. You have an iPhone app connected to the stream endpoint, and there's some analytics endpoint that sends you a summary email once a month about how much money you save by using this app. If you want to go play with this, or if you're interested in this simulator I built, I have a GitHub account. If you find my Twitter ID, it's the same as that on GitHub, and you can go play around with this, this simulator I built. But if you look at this, there's a lot of symmetries in this, and it looks complicated, but actually it's a very simple architecture. Each of those little circles, each of those little blobs does exactly one thing. It's very simple. They're arranged in a very symmetric way. So when you're trying to build systems, then, there are some principles that will keep it simple, particularly if you're building sort of large-scale, sophisticated architectures. One is to maintain symmetry. Right? If you're building a multi-region system or a multi-zone system on AWS, if you put exactly the same things in every zone and every region, you're making it symmetric. That's the Netflix model for deployments. They can lose a zone, the system keeps running. They lose a region, they switch the traffic to the other region. There's no customer outage. Right? You can build symmetry in, but if you put a special machine, hey, this machine's only needed in one place, well, we'll only put it in one place. You've broken symmetry. You've actually made the system more complicated. So every time you break symmetry, maybe for efficiency purposes, but you're actually making it more complex. So think about that trade-off. Don't just assume that efficiency is good for goodness sake. What you're really doing is you're creating invariance. And invariance is a really powerful concept, a thing that doesn't change across time or across space is the things that make things simple. And you're creating assertions. You're making assertions that this is an invariant, this is a symmetry, and those assertions are the things that let you deal with really complex, large-scale environments. I mean, there is a tiny number of people at Netflix running a huge global system with tens of thousands of machines in it, and because of these principles. And think about systems thinking. Think about how to set up the feedback loops. Putting your developers on call is a system that provides feedback. It takes the pain and puts it where the pain can have the best benefit, right? So think about setting up feedback loops to make people do the right thing rather than writing down a process and making them follow it, right? That's the idea here. So that's basically it. This is just the final thought again from the systems thinking book. We see the world as increasingly more complex and chaotic because we use inadequate concepts to explain it. When you understand something, it no longer see it as chaotic or complex. So thank you. And I think it's great.